Hello everyone, hope you're doing well. Welcome back to my channel. Today we're at day 15 of the February Daily Leetcode Challenge. We are almost done with half of the month. So if you have been consistent till this point, a big congratulations to all of you. Today we have a very good question. Okay, this question will look vague because it has no real life implementation. Like there's no real life application of this kind of question. But again, to test your grip on your coding, I will say this question is really good one. Okay, now what is this question? Let us quickly begin with that. Before that, let me open the output window so that things will be more clear for you. So today I have taken the edge case here. N is going to be till 1000. So I have taken directly the last possible case. Okay, and then I will trying to show you what are all the possibilities here. So basically, this question is revolving around certain things. Okay, these are the certain things that you will be seeing. Okay, so yep, let us quickly begin now. So see here what we are given. So basically given a n, okay, n is going to be a number between 1 to 2000, and then what you do, let us see. Given a positive integer n, return the punishment number of n. So what is this particular stuff? We will see that now. Okay. The punishment number of n is defined as the sum of squares of all the integers I such that they go. They are trying to say that the punishment number of n is basically sum of squares of all integers I such that I is between 1 till n. Okay, so I is going to range between 1 till n. Remember, n is inclusive here. Both 1 and n are inclusive. Okay, as simple as that. Then this statement is something that I will say, like, see, with a single but just by reading this a single time, I don't think you will be able to understand. You have to see multiple examples, especially example number 2 is something, especially this particular line. Okay, this particular line basically helped me to understand this whole program. Okay, so I am expecting you to go through the same, and for you I have kept multiple examples so that you can get a good grip of the whole question. Okay, now see here, the decimal representation of I into I, that is the decimal representation of I square, can be partitioned into contiguous substrings such that the sum of integer values of these substrings equal to I. So what it means, I will show you now. Okay, so let me quickly take one example. Let me show it to you. Okay, so see here, let us talk about this. Okay, let us talk about I is equal to 82. Okay, why this is I? See, first of all, I is going to be just a number between 1 to n. Okay, so currently I'm the output which I'm showing it to you. Okay, this is for I n is equal to 100, n equal to 1000. Okay, so this is the output for n equal to 1000. If in that, I'm just showing you the output for one I. Okay, just to explain you what this particular statement means. Okay, so first of all, see, let us say I is equal to 82. The square of this is, that is 82 square, is going to be 6724. Okay, now I have to take this as a string. Okay, like try to imagine this as a string. So since there is a string, you'll have to break it into substrings. Okay, that is what they're trying to talk about. They are trying to talk about substrings. Okay, so I have to break this particular string into substrings in such a way that when I add those substrings, okay, when I say add, I mean like when I add the integer version of those substrings, I should get the original I back. Okay, I will again repeat. I is 82, I square is 6724. The square number, okay, that is the 6724 that you're seeing here, should be taken as a string. Okay, I will have to break this string into substrings, and then when I try to add the integer version of the substrings, I should get the original I back. Okay, it is like a cycle. Okay, we are starting with I and we are going to again end with I. Okay, see, I'm going to start with I'm going to calculate I square, which is 6724. This 6724 should be taken as a string now. This 6724 should be broken into substring now. Once I break it down substrings, I should be able to get the original number I back when I try to add the integer version of those substrings. Okay, let us see this example. 6724. So I'm trying to make it like this. Okay, 6 is here, 72 is kept together. Okay, this is also a substring, and then 4. Okay, 4 is kept separately. Now if I try to add them, the integer version of these things, I mean, see, 6 plus 4 is basically going to, okay, let us do it this way. 6 plus 4 is 10. Okay, 6 and 4 are giving you 10. 10 plus 72 is 82. So you are getting 82 back. So that is what is the trick behind this whole question. You have to take I, get I square. This I square should be treated as a string. Once you get this as a string, you have to break it into substrings. Okay, remember they're talking about contiguous substring. That means every letter here basically should be included. Okay, 6724, every letter in this thing should be a part of a substring. Okay, simple as that. So I'm breaking it like this: 6 plus 72 plus 4, and then I'm getting the original I back. Okay, so the whole question basically revolves around the topic of, when I have a string, how to break it into substrings like this in such a way that I am getting the I back. Okay, as simple as that. So this is the whole question about. So I will again repeat what is the question. Once you are given a number n, you will have to go through all the numbers between 1 till n. Okay, and then whichever number satisfies this particular condition, take that number, take the square of that number, add it, and then you are going to get the answer. Okay, I will explain this again with the example number 2. See here, when, see here, n is 37, that means I will have to go through all the numbers from 1 to 37, both inclusive. Okay, then I have to see which all numbers satisfy this property. So here we are, some of the examples. See, in this case, 1 is satisfying this property because 1 square is also 1. Okay, and when you write this 1, basically there is only one term, so obviously this particular substring and this particular number is same. Okay, so this satisfies this property. Let us go to the next one. See, I equal to 9 also satisfying this. I equal to 9, I square is 81. So I am going to write 81 like this. So when I try to add the substrings by converting to integer, I'm going to get back 9. Okay, so 8 plus 1 is equal to 9. So I'm going to get back 9. Okay, now take 10. The square of 10 is 100. I can write 100 like this. And when I add the substrings by converting them to integer, I'm going to get back my I. Okay, as simple as that. 10 plus 0 is 10. Okay, now coming to 36, this is a very good example. That's why I mentioned. See, this part is going to be a very good one. Because of this, you are going to get a lot of clarity of this question. Okay, without this, I don't think we'll get much clarity on what this question is all about. Okay, see here, I equal to 36. The square of 36 is going to be 1296. 1296 is your string. You have to break it into substrings. Okay, so this is how I have broken it into substrings. Okay, 1 separately, 29 separately, and 6 separately. So when I add them, basically, okay, so see, 29 plus 6 is going to give you 35. 35 plus 1 is going to give 36. We are going to get back 36. So that is the reason why even this is satisfying this property. So how, see, that is all right. So from 1 to 37, only 4 numbers are satisfying this property. They are 1, 9, 10, and 36. Now, how to get the answer? Remember, this is not the answer. How to get the answer? The answer is going to be whichever number among 1 to any satisfying this property, take the square of them, and then the sum of the squares is going to give you the answer. See here, the sum of squares of all these numbers is going to give you the answer. So, what is the answer now? 1 plus 81 plus 100 plus 1296 is going to give you the answer, and that is what is going to, this is what is the final answer. Okay, how that is coming? 1296 plus 100 plus 81 plus 1. Okay, if you add all of them, you will be getting this particular number, and this is your answer. Okay, if you see the calculations here, basically they have done the same. 1 plus 81 plus 100 plus 1296 is going to be 1478. That is your answer. Okay, so I hope the question is very clear to you. Everything is clear to you. See, at first the question itself is not clear to many people, so I'm expecting that now it is clear for you. Okay, now today I have two codes for you. Okay, one is the code that you have to submit, and the other code is the one in which you will be able to basically debug better. Okay, because see, here I have the way I've added the things. Okay, I've added multiple new stuffs here. Okay, these particular stuffs are new here. Because of these, you will be able to get an output like this. Okay, where you can understand basically how exactly things are working. Okay, so I've done, see, for 1000 I've taken this. Maybe this whole part I can give as the output, so that you basically know for a number how the real answer is coming. Okay, so for big numbers like this, how the answer is coming, you get a clarity on that. Okay, as simple as that. So let me show the Excel code. Remember, in the actual code I don't have those output statements and all. To get those output statements, I have to add additional stuff. Okay, like additional parameter in the function, and additional, maintenance of that particular parameter, like this, pops, appends, and all that, right? So let me show the code in which I am not doing all that. Okay, because this is the real code that you have to submit. Okay, now what I'm doing, see, answer equal to 0. I'm going from the numbers between 1 till n. Okay, then for every number I'm calculating its square. Then this square I'm passing it in a function. Okay, in this function, what all I'm passing the string of the square, I'm passing the actual number I. Okay, and finally I'm passing the index to start with, which is 0. Okay, now if this function returns 2, that means this can be partitioned into substrings whose sum is going to give you the I back. Okay, if that is the case, whatever is the square, add it to your answer, and finally, once everything is done, you have to return your answer. Okay, now let's go to this function, what this function is doing. Okay, now if you come here, you are getting a string, you are getting a target, you are getting an index. Okay, let's see what is happening. These are the two basic conditions because of which your recursion will stop. Remember, this is a recursive function, so these are the two conditions which will stop the recursion from progressing further. Okay, so we'll come to them at last, because remember, to understand these functions, you have to basically see the rest of the code first. Okay, so let us start with that. Current sum equal to 0. I am going to start with the current index till the last index n minus 1. You can say, like, see, n is already used, so let me not say n minus 1. I will say the length of the string minus 1. Okay, as simple as that. So I is going to range between index till length of the string minus 1. Now, so what I am doing, see, I am, see, current sum is 0 initially, so current sum into 10 plus the current index, after converting to integer, I am adding it, and then I'm storing the current sum. So one thing that you will ask me is why I'm multiplying with 10. See here, so basically in this case, if you see, yep. See, 72. No. See how to get 72. Remember, this should be treated as a 72, not like 7 comma 2. Okay. 72 means 7 is in the tens place, 2 is in the ones place. Okay. No, so this should be treated as 72. So how to get that? See, 7 needs to be multiplied with 10, so it becomes 70, and then you are going to add 2. Okay. So that is what I've done here. The current sum should be multiplied with 10, and then I'm going to add the integer version of the current number. Okay. Current index. Okay. This is the current sum. Now, if at any moment the current sum becomes greater than or equal to target, we have to return. Okay. Now you will ask me how to break them. See, after 6, why you are breaking it? How to start 7 2 separately? For that reason only, I am at every step, that is every iteration. Okay, I am going to call a recursive function again with different parameters this time. So how to do that? See, I'm again passing the same string. This time, since my current sum has been calculated, the target. Okay, remember, this is your target. The target is going to be target minus current sum. Okay, and then since the current index I has been already processed, so I'm going to call the index I plus 1. Okay, so this I plus 1 is basically going is something that the next function call will start with. Okay, so for the next function call, this index is going to be I plus 1. Okay, and similarly the target is going to be target minus sum, and this is going to be then your new target. Okay, as simple as that. If this function returns 2, okay, we will be returning 2 here, otherwise we'll be proceeding with the other iteration of the function call. So let us see now the the base conditions here. Now this will make more sense to you. See, the idea here is, since they are talking about contiguous substrings, so the idea here is we will have to consider every integer here. So if you see, for example, 6724, so every number in this string should be considered. Okay, that is the basic idea. So for that reason, I'm just checking in my ending terminating conditions, if index is equal to length of string. Okay, in that case I will say that all the index have been processed, and if target equal to 0, that means all the strings, that is all the characters in the string have been processed. At the same time, the sum that I am getting is equal to 0. If you see, this is the target, how we are returning the target. Okay, this is your target. So if target equal to 0, okay, you have written true. Okay, this is your first stop condition. If say, sometimes what will happen, no, you will reach index equal to length of string, but your target will not be 0. In that case, you have written false. So that is what we are doing here. If index is greater than or equal to length of string, so then we have written false. Okay, as simple as that. So these are the two terminating conditions for a recursion. Okay, as simple as that. And now that will be a case like this. See, there will be a case like this where we don't have to break anything. The string itself is a substring whose sum is going to be your I. Okay, in that case, this condition will be helpful. Okay, this condition. So if you see after the for loop, okay, we are doing this. If the current sum, if you see at every iteration, we are doing the current sum, right? So at the end of the iteration, if the current sum is equal to target, in that case also we are returning true, otherwise we return false. So that is how it is working. This function call will return true if the current index I, that is the square of the current index I, can be partitioned into substrings whose sum is equal to I. Okay, as simple as that. If that is the case, add the square to the answer, and this will keep continuing. This whole for loop will keep continuing. At last, we attain the answer. Okay, this maybe I will give you both the codes. See, if you see the difference, no, here I have to keep a substring. Okay, here I'm not keeping any such thing. Okay, so just to make you understand like how this whole code is working and how these outputs are coming, for that reason I have done this. Maybe this whole part I can give you in the comment section, so you can go through that. And if you have any doubts, no, you will be able to know why and how this particular string is behaving like a this punishments number. Okay, in order to calculate the punishment number, how the distribution, that is how the partition of the string is happening in such a way that their sum is going to give you the original I back. Okay, how that is happening. So for you to understand that, I have done this part. Okay, I've taken directly 1000, which is going to be your edge case. See, 1000 is the last number that you can get. Okay, the highest number that you can get. So I've directly taken 1000. I've taken this output. So this will be helpful for you. Okay, so I will give you both these codes, or maybe the original code and the output of the second code. Okay, I will give you that so that you can understand what is happening. Okay, yeah, friend, that was all for this particular video. If you like my efforts, if you like the quality of my content, please do subscribe to the channel. This really gives a lot of motivation to continue further. Remember one thing, I know that you might not have understood everything in this video, but my aim is I can give you a path. Okay, I can give you a kind of summary, the actual implementation to understand and the ground root level. Okay, to understood at the grassroots level, you will have to go through this code, and you will have to understand every part. Okay, so that's why I always give my code in the comment section. You now know how this code is supposed to function, but the exact implementation part, you will have to go and check out each and every line, and then you will understand it. Okay, that is how you have to do it. So please do not expect everything to be taught in a single video. So that is not possible. Believe me, that is not going to happen. Everyone has a different ideology. Everyone thinks in a different way. So this is what I have thought of and how I've got the solution. Maybe you think in a different way, you will try to conceive this particular stuff in a different way. So that is why I'm saying, take this code, add some more print statements, start to understand what is happening. Maybe you will learn a different approach, or maybe you will be able to optimize the same code. Okay, as simple as that. So yeah, and that was all for this video. I hope you are liking this content. You are getting some quality content back. You are getting some different ideas. If you like this effort, please do subscribe to the channel. This was my 116th day of continuously uploading videos on LeetCode. And yep, I guess there are more to come. See you tomorrow. Thanks a lot.